You ever feel like you're building a distributed system with, I don't know, duct tape and prayers? You grab a storage engine here, a consensus library there, and then you spend weeks writing all this messy glue code. You end up with this fragile monster that's just an operational nightmare. We've all been there, right? I mean, let's be real. This is what the puzzle usually looks like. You start with a great storage engine like RocksDB. You pull in Raft from etcd for consensus. Maybe you roll your own custom locks for transactions. And then you try to slap a Redis-compatible API on top of the whole thing. Each piece is a beast on its own. But making them all play nicely together? Yeah, that's where the real headache begins.
But what if you could just skip all that? What if all those essential battle-tested components came pre-assembled in one high-performance package, written entirely in clean, beautiful, pure Go? Well, that's pretty much the core promise of NoKV.
So how does NoKV actually pull this off? Let's pop the hood and take a look. We're going to start with the basic key value idea, then check out its wicked fast storage engine, unravel the distributed magic of MVCC and Raft, and then, and this is the fun part, we'll zoom in on 3 really clever innovations that make this project shine. After that, we'll spin up a cluster live, and I'll show you exactly how you can jump in and make your first contribution. Okay, let's start at square one. At its heart, NoKV is a distributed key value store. But what does that actually mean for us as developers? It's a beautifully simple model. You've got a unique key, think of it like a word in a dictionary, and a value, which is the definition. It's incredibly flexible, and this simple idea is actually the bedrock for so many of the complex databases we use every single day. Okay, so we have this simple key value model, but how does NoKV get that data onto a disk so efficiently on a single machine? Well, this is where its clever storage engine, built on something called a log-structured merge tree or LSM tree, comes into play. So imagine the LSM tree is a hyper-efficient librarian. When a new book comes in, instead of painstakingly finding the perfect spot on the shelf right away, the librarian first just jots it down in a log to be safe. That's our write-ahead log. Then they pop it onto a temporary new arrivals table for super quick access. That's the in-memory memtable. It's only later, during some downtime, that they actually sort these new books and merge them onto the main shelves. This whole process makes writing new data insanely fast. But what if that book is a massive encyclopedia? Trying to sort and merge that thing with a bunch of tiny paperbacks is just inefficient. It slows everything down. So NoKV, taking a cue from BadgerDB, does something really smart. It separates the big stuff. That giant encyclopedia goes into a special storage area called the ValueLog, and only a tiny library card, a small pointer, is left in the main sorting system. This keeps the core LSM tree incredibly lean and makes those background merges, the compactions, lightning fast. So we've got a fast single-node engine, that's great, but how do we take that and turn it into a robust, truly distributed database? This is where we get into the really cool stuff, consistency and massive scale. Let's talk transactions. NoSQV uses something called multi-version concurrency control, or MVCC. And honestly, the best analogy for it is Git for your database. Every time you write, you're not overwriting the past, you're just creating a new version, a new commit, with a timestamp. This is a huge deal because it means different clients can read a perfectly consistent snapshot of the data from some point in the past, all without interfering with each other. And to keep all of this consistent across a whole fleet of machines, it uses Raft. Think of a Raft group as a choir with a conductor, the leader. The leader decides what data to write and makes sure all the singers are perfectly in sync. If the conductor faints, the choir just quickly elects a new one, and the show goes on without missing a beat. Now, imagine you don't just have one choir, but a whole music festival. NoKV does this with Multi-Raft, splitting the data into regions, where each region has its own independent choir. This is exactly how the system scales out so beautifully. All right, so we've got a fast storage engine and a scalable distributed layer. But here's where NoKV gets really clever. Let's dig into 3 key engineering innovations that give it a serious performance edge. First on the list is the commit worker. Just imagine a really busy database. If you handle write requests one by one, you create this massive traffic jam of lock contention and slow disk I/O. It's a classic bottleneck. The commit worker is basically like a carpool lane for your writes. Instead of every single request driving to the disk all by itself, they all line up in a queue. Then, a single, dedicated worker groups them all into a batch and writes them all at once. One disk sync can serve dozens of clients. This drastically reduces overhead and just cranks the throughput way up. And this actually brings up a great question for all of you. When you're thinking about performance for your workload, what's more important?
Is it that super predictable, low latency, like a solid P99, or is it just raw, maximum throughput? Drop a comment below. I'd genuinely love to know what kind of benchmarks we should prioritize for this.
All right, the next piece of clever engineering is the ingest buffer. This is all about handling those sudden, massive bursts of traffic without even breaking a sweat.
Think of your LSM tree as a river. A sudden, massive downpour of writes can cause a flash flood, stalling out the entire system. The ingest buffer acts like a reservoir and a dam. It catches that flood of new data in a staging area with a super cheap metadata update, and then it releases it downstream at a controlled, manageable pace. This lets the system absorb huge traffic spikes while maintaining really smooth, predictable performance.
And the third innovation is called the hot ring. You know, one of the biggest challenges in any database is just knowing what your most frequently accessed data is, your so-called hot keys. The hot ring is like a lightweight built-in detective that's constantly sampling data access to identify these hotkeys, and this is incredibly powerful. It can tell caching layers what data to pre-warm, it gives you the power to throttle writes to a specific key that's causing trouble, and best of all, it makes all this data visible so you can actually debug performance issues. So here's a thought. What other policies would you want to see for handling hot data? Let us know by opening an issue on GitHub.
All right, enough theory. This is all cool on slides, but let's actually see this thing in action. I'm going to show you just how ridiculously easy it is to spin up a distributed, fault-tolerant NoKV cluster right here on my machine.
Okay, check this out. First, I'm going to run one script to start a 3-node Raft cluster. Boom. Done. Next, in another terminal, I'll start the Redis protocol gateway. And that's it. We're live. Now I can just connect with a standard Redis client and start firing away commands. Let's try set hello world. Okay, get hello. Nice. Increase counter. It all just works. The real beauty here is that you're using tools you already know to talk to this incredibly powerful distributed backend. I seriously encourage you to try this yourself. Fork the repo, run the script, and if you hit any snags at all, please open an issue.
And that ease of use brings me to my final and, I think, most important point, how you can get involved with this project.
I love this quote because it perfectly captures what NoKV is all about. This isn't just another database. It's an open-source distributed systems masterclass, all neatly packaged in pure Go. It's a fantastic project to learn from, to experiment with, and to contribute to.
So if you're a Go developer or a distributed systems enthusiast, this is a project you'll definitely want to check out. And getting started is way easier than you think. There are plenty of great first issues just waiting for you, from improving the documentation and adding more Redis command tests to building better benchmarks, or even implementing a chaos test for the Raft layer. Head over to GitHub, give NoKV a star, watch the repository for updates, and find an issue that sparks your curiosity. Let's build it together.